Hey guys, today's question is count number of bad pairs. In this question, we are given with an array nums, and a pair is bad pair when the pair ij is I less than j and j minus I not equals to nums j minus nums I. Okay, and we have to count the total number of bad pairs and return it. Okay, like in this example, we can see there are multiple bad pairs. Total number of pairs can be 6. Okay, and the number of bad pairs is 5 because the only good pair is this one 3 1. Okay, as you can see 3 1, the I is 1 here and j is 3. Okay, so 3 minus 3 equals to 1 minus 1. That means it is a good pair. Okay, so what we will do, what will we approach is, we can't find bad pairs easily, so what we will do, for every element we can find good pairs easily. Okay, and the total number of bad pairs for every element in the left side will be total number of will be the will be the index. Okay, like for this element the total number of pairs that can be formed is 3 1 and 3 4. Okay, so the index is 2. Okay, so the total number of pairs will be the index, like for example I, and total number of good pairs we can find, so total number of bad pairs will be index minus total number of good pairs. Okay, so we will simply find good pairs in the left side, and then we will calculate our bad pair for every index by the formula that I told. Okay, and how can we find good pairs is as the given equation j minus I not equals to nums j minus nums I. Okay, this is the equation for bad pair. So for the good pair the equation will be j minus I equals to nums j minus nums I. Okay, like for this example, if I write this equation, this is for the bad pair, so for the good pair there will be double equals to. Okay, so j minus I double equals to nums j minus nums I. Now if we simply shift nums j in the left side and I in the right side, what will happen is, we take it, so it will become the minus when gone to the left side, and the minus I when I shift it to the right side, it will become positive. Okay, so the equation resolves for the good pairs is j minus num j double equals to I minus num I. Okay, so we simply need to track the difference. Okay, so j minus num j is the difference between the current element and the index, and I minus num I is also the same. Okay, so why this was a good pair, as you can also observe, because the index minus the current value 3 minus 3 was equals to 1 minus 1, which was 0. Okay, that's why it was a good pair. And number of bad pairs will be simply for this 3, total number of pairs that can be formed is 3, which is the index, minus the good pair is 1. Okay, so total number of bad pair is 2. Okay, now for this 3, total number of bad pairs is again 2, and for this one, total number of bad pair is 1. So total summation of the bad pair is 2 plus 2 plus 1, which is 5. That is our answer. Now in this example you can again see 3 5 4 2 1. You can see that all the equations, all the pairs, any pair that you will form, like 5 3 5 2 5 4, and yeah, or 4 3, every pair satisfies this equation, so every pair is a good pair. Okay, 5 minus 4 equals to 4 minus 3 equals to 3 minus 2 equals to 2 minus 1 equals to 1 minus 0 equals to 1. Okay, and now for this 4, like let's take a name element like 1. Okay, so this pair 4 minus 3 equals to 1 minus 0, which is 1. Okay, so what we will simply do, we will track the number of, we will track the differences that are taken before. Okay, like we will simply take an unordered map, and now for this 4, okay, for this 4, total number of good pairs that can be formed is the number of elements that have the difference, that this element have the difference with with its index. Okay, so with its index the difference is 4 minus 3 equals to 1, and we have already calculated these elements before, because we will traverse from left to right, so these three elements will also have a difference 1 with their indexes. Okay, so we'll simply update the difference in an ordered map, and when we are at an element, we will simply check how many elements in the left side have the same difference as the current element. Okay, for this example, the current difference, like when we start from 4, so the difference will be 4 minus 0. Okay, and the left side there is no element which has the difference 4 minus 0, which is 4. Okay, so the total number of goods pair in the left side is 0. Okay, in this, for this one, we can see the difference is 1 minus the index is 1, which is 0, and the total number of elements which have the same difference 0 are none, because this 4 has the difference 4 minus 1 equals to 3 that we updated. Okay, so let's simply write the code for this to understand it well. Initially, let's take the sum as long as given. It can be very big, so long sum equals to 0, And now we have to take an unordered map to store the differences, okay, for the index, so that we can use this equation to find total number of good pairs at every point, and we will simply subtract it by the index to get the number of bad pairs in the left side for every index. Okay, so we'll simply iterate for int I equals to 0, I less than nums dot size I plus plus. And now what is the current difference for this element is the current difference equals to nums I minus the index. Okay, minus I, this is the current index, uh, this value. Okay, we can take in reverse, simply subtract the equation by -1, multiply this equation by -1 equals this. And now what we can do is we will simply add our sum. Total number of good pairs, as I explained before, will be the index, which can be the total number of pairs in the left side, minus the elements which have same difference as this element. So the same difference, which is current difference. Okay, we added this value in our sum, and we have to update the map again for this difference. So diff of current difference